Right, welcome back. Let's do question 8b. Right, we managed to do question A, but let's just go through the information. Given cos theta is equal to a squared minus b squared divided by a squared plus b squared, where b is greater than 0 and a is greater than b, and sin theta is negative. Determine tan theta in terms of a and b. We managed to do that. We managed to find that tan theta is equal to negative 2ab and then over a squared minus b squared. That's what it did in question A. Now question B. It is further given that a is equal to 3 and b is equal to 2. Solve for theta where theta is between 0 and 720. But remember, we discussed about our Cartesian plane, right? We said that our angle is in the fourth quadrant. We have to substitute our a and b and see what we're going to get for our theta. So tan theta is equal to negative 2 then times 3 times 2 over 3 squared minus 2 squared. And then what do we get? We must get negative 2, 4. Okay, so tan theta is equal to negative 2, 4. And then our theta is going to be arctan, the inverse of tan, then negative 2, 4. This will give you a reference angle which is negative 67.4 degrees. Round off to 1 decimal place, otherwise it should be negative 67.3801. For tan theta, remember our general solution, we're going to use the formula method, but if you are comfortable with the quadrant method, you can use the quadrant method here. So the formula method, our angle theta is going to be our reference angle. This is the reference angle, okay, and then plus 180 degrees times k, where k is an integer, right? And then we're going to use our calculator for this, right? Negative 67.4 degrees and then plus 180 degrees times k, where k is an integer, right? So we're substituting k with integers like negative 4, negative 5, negative 3, negative 1, 1, 2, like that. And then what angles are we going to get? Let's go to the calculator. Alright, let me show you how you are going to get the angles from the general solution using a calculator. So what you do, you press mod and then look for the table. In this calculator is 7, number 7. In other calculators maybe number 3. So you press table and then put the function negative 67.4 plus 180 times k. So you press alpha x there for your variable there for k, right? And then equals, we don't have the second function, so we're going to press equals again, right? And then start, right? We can substitute maybe from negative 3 to positive 3, right? So maybe just to be safe, because this domain seems to be big from 0 to 720, so let's say maybe from negative 5 and then we're going to end at 5. Then the step is 1. Okay, what does that mean? Yes, you're substituting there using negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, up to 5, like that. So the step must be 1, and then press equals, and then these are the angles, right? Okay, these are the angles. Our domain is from 0, so we're going to start from 112 there. We're going to discuss this, right? It's not all of them that are going to be the solution. So here 292.6 degrees, 472.6, 652.6, and then 832.6, like that. So these are the angles we got, right? And then from these ones we must be able to get our solutions. We managed to find these angles from the calculator. Our angle must be in the fourth quadrant. So which angles are in the fourth quadrant here? This one is out. This is in the fourth quadrant. Remember, fourth quadrant is from 270 to 360 degrees, right? So this one is in. Then 472 is an angle which is more than 360. Just say 472.6 degrees minus 360 degrees. What do you get? We're getting 112.6 degrees. This is in the second quadrant, so it's out. This one's out. And then we're also saying we have the 360, right? and then plus 112.6, that will make 472.6. okay, so it's in the second quadrant. And then 652.6, if you subtract here, what do you get? 652.6 degrees minus 360 degrees, what do you get? We get 292.6 degrees. So this is in the fourth quadrant, so this is in. This one is above 720. So our solution here will be theta is an element of 292.6 degrees and 652.6 degrees. You could have used what we're given. Remember, we're given this, so we could have used this, right? Cos theta is equal to a squared minus b squared over a squared plus b squared. So we substitute here. Cos theta is equal to what? A squared is going to be 3 squared minus 2 squared over 3 squared plus 2 squared, which is like 5 over 13. And then theta is equal to cos 5 over 13. And then what do you get? 67.3801 goes on like that. So this is like 67.4 degrees, right? Then this is our reference angle. This is our reference angle, right? And then now remember, for cosine, our theta is going to be positive or negative reference angle, then plus 360 degrees times k, where k is an integer. Right, our reference angle here, you put this, so it's going to be theta is equal to positive or negative 67.4 degrees plus 360 degrees times k, where k is an integer. Then you can put this in the calculator. Let's go to the calculator. Right, for our alternative method, you're going to do the same thing. Right, for cos theta, we have what? Positive or negative 67.4 plus 360 times k. So how do we do that? You press mod, and then table, in this calculator 7, then press the first one. Let's start with positive 67.4, so 67.4, then plus 360 degrees times k, so we say alpha x, then equals. Then we put the second function now, which is negative 67.4, negative 67.4, then plus 360 times, and then for k you press alpha x, like that. So we've entered our two functions, and then let's start again and let's say negative 5, right, and then up to 5, and then step we make it 1. I explained why we're saying 1, because we're substituting these integers from negative 5 up to 5. So it's negative 5, negative 4, negative 3, like that, up to 5. So the step must be 1, and then equals. So these are the angles that we get for the two functions, right? And then we have to select the ones which are applicable for our question. Again, we're getting these angles. Again, we have to look for our angles in the fourth quadrant, and we say it is this one and this one. Okay, our theta is an element of 292.6 degrees and 652.6 degrees.